Okay, we want to look at partial fraction decomposition of a couple of forms that we haven't seen previously, where we have the square of a quantity of a binomial in the denominator. And in the numerator, we could either have ax plus b, or just a, or just ax. Any one of these forms can be handled in the same way. We simply set the, well, take an example, 2x plus 5 over the quantity x minus 4 squared. We'll write this as a over x minus 4 plus b over x minus 4 squared. Putting this over common denominator, x minus 4 squared, we have to multiply numerator and denominator of this fraction by x minus 4. And I'm going to include the standard step, just to reinforce it. Okay, so we multiply the first fraction by x minus 4 over x minus 4, which will make the denominator x minus 4 squared. And this, of course, gives us ax minus 4a over x minus 4 squared plus b over x minus 4 squared, which is then ax plus, I'll write it this way, b minus 4a with quantity x minus 4 squared. So now this equals this. So the numerator has to equal the numerator. Since this has to be true for all values of x, a has to be equal to 2. And then b minus 4a has to equal 5. Well, if a is 2 and b minus 4a is 5, well, that means b minus 8 is 5, so b is 13. And now we can say that 2x plus 5 over x minus 4 quantity squared is equal to 2 over x minus 4 plus 8 over x minus 4 quantity squared. Now, the same idea works whether we have just a number here or just a multiple of x here or a multiple of x plus a number. Okay, so for example, if we just have the 2x, or let's just say, okay, any fraction with denominator x minus 4 squared with numerator of lower degree than the denominator is going to be subject to this decomposition. Okay, so if we had 7 over x minus 4 squared, well, that would still be decomposed as a over x minus 4 plus b over x minus 4 squared. Same thing. And of course this comes down to this. So that's ax plus b minus 4a over x minus 4 quantity squared. So in this case, AX equals 0, meaning that A is 0. And B minus 4A has to equal 7. Thus, A equals 0 and B equals 7. And our partial fraction decomposition just becomes seven over x minus 4 quantity squared equals 0 over x minus 4 plus 7 over x minus 4 squared, which is just 7 over x minus 4 squared. So we really didn't get anywhere with this, did we? Now, if we had, I mean, this just shows that this is already in its decomposed form. But running through the process confirms that. Okay, if we had negative 3x over x minus 4 squared, that would equal, well, this, which equals ax plus b minus 4a over x minus 4 squared. So ax equals negative 3x, b minus 4a equals 0. So we solve this. From this one, we divide through by x, and we get a equals negative 3. Then we have b minus 4 times a, which is 4 times negative 3, 0. So b equals negative 12. Thus, negative 3x over x minus 4 squared equals decomposition's a over x minus 4, a is negative 3. Plus b over x minus 4 squared. Of course, that's negative 3 over x minus 4 minus 12 over x minus 4 quantity squared. So we see that no matter what the denominator is, or sorry, no matter what the numerator is, the decomposition is going to be this, and we just have to match up our coefficients.